Okay, guys, hi. I just need to reference something here to orient our mind space. So I want you to be reminded of this diagram here. And let's be reminded of Roy Spencer's argument, or not his argument, just his point that he made that the sunlight being intercepted by the Earth gets spread over the full sphere of the Earth. And he says that that's basic geometry because area is important. Now, it's not only Roy Spencer who said this to me. I've had a physicist at my own local university say this to me. And I've had many other people, random people on the internet say this to me, and just people all over, people with degrees and people with no education whatsoever. So let's just reference this, right? So they're saying that that sunshine doesn't fall like this, only over a hemisphere at once, right? The per second input, the instantaneous input. They're saying that the instantaneous input of sun on the Earth gets spread over the entire surface area of the Earth at once. And therefore they divide the solar flux, the solar power, by 4, because that's the ratio between the disk cross section and the surface area of a sphere is a factor of 4. And then on paper, they make, obviously, then the solar input becomes freezing cold, minus 18 degrees Celsius, and then they invent this fake greenhouse effect where the climate has to create itself. And they say that that's basic geometry. They're very serious about that. These people have PhDs in physics. I mean, we should very much listen to them, right? These are people with PhDs in physics, PhDs in climatology, PhDs in astronomy, who are saying this to me, and people with no education whatsoever are also saying this, right? And repeating it. So this is very important. We should listen to these people, right? Because they are very highly credentialed. We should definitely very much listen to them that the solar input gets spread over the entire surface area of the Earth in the way that they do. And as for this down here, where the sunshine is only falling on a hemisphere, well, I'm just not sure about that, are we? Right? So I need to do a demonstration. I'm going to do a demonstration tonight. Okay. So this is going to be a real physics demonstration. Now, to tell you the truth, I'm a little bit embarrassed about having to do this demonstration. Like, I feel a little uncomfortable doing it. It's a little bit embarrassing for me to do it. It's not that it is embarrassing in and of itself. Like, for the right audience, for people of a certain stature, short stature, I'd be quite happy doing this demonstration that I'm about to do. It would be very interesting, and I'm sure they would all very much love it. But for the audience who I have to do it for now, physicists, PhDs in physics, and PhDs in astrophysics, and PhDs in climatology, it's just a little bit embarrassing that I'm doing this. Nevertheless, we'll do it, and we'll try to have a lot of fun. For the people who understand why I'm doing this, obviously you will enjoy why I'm doing it, and you'll enjoy watching it. And you will understand that it must be quite embarrassing for the people who need this to be shown to them. So I am going to switch my inputs here and give this demonstration, and then I will be back. Okay, guys, here is my DeWalt flashlight, workspace flashlight. Now, what I'm doing is I'm going to use this flashlight as a make pretend sun, okay? Now, obviously, for the scientists, for the PhDs in physics who are watching, this is not actually the sun. It's just a pretend sun, and it's shining in only one direction. But of course, the sun would be, a sphere shining in all directions. But we're only interested in the sunlight that makes it to the planet Earth. And so this light is shining in one direction. And then I've went out and bought for you guys so that I could show you. I bought a globe. That's the Earth. See? So what I want to show is that this globe is a little bit transparent, translucent, so there's some light shining through it, but you can sort of get the idea. You can mostly get the idea here that you see when the sun, or when the light comes from the sun, that pretend sun over there, that the light only falls on one hemisphere of this planet, right? And what happens is this planet is actually rotating. See, it rotates like this. And at any time, points on this planet, on the planet Earth, rotate into the sunlight here on one side. And when it reaches here, for example, this point on the equator, rotates into the full power of the sunshine in real time. And of course, the power of this sun decreases as the angle of incidence that the light falls upon. So if all these light rays, photons, are coming at the Earth parallel, in a parallel ray, all in the same direction, which of course they do from a point source, which is the sun, then they fall with an angle of incidence. And the angle of incidence is the cosine, and that gives the projection factor. Well, the angle of incidence from the zenith angle. So the zenith angle points here directly towards the sun. That's the zenith. And then the zenith angle is the angle away from the sun towards the terminator. And the terminator is the part where it turns from light to darkness, or daytime to nighttime, right? So the zenith angle decreases going up like this, or it increases actually, and it's 0 here, and it increases to 90 degrees when it's perpendicular to the incoming light. And in any case, that is how the planet rotates underneath the incoming input. You can see that that light doesn't actually get spread around to the backside of the Earth, to the backside of this globe, right? How would that happen? How would this light that's falling here, like, you can see that it's not happening, right? Like, this is a real empirical demonstration that the light that's coming in here on this hemisphere isn't falling on this backside, is it? This backside is actually in darkness. It's actually dark back here. So you can see the shadow on my hand. See, we come up, there's the light coming over the Earth that didn't get intercepted, but then back here, it's all in darkness. So there is no light from the sun that's making it back here. So you can't take this input light and average it to back here as well, because it never exists back here. As the Earth rotates underneath, you have points on the surface which rotate into the intensity, the full intensity of the sun. And like I said, the intensity is given by the projection factor, which is the cosine of the zenith angle, right? So that's how that works. So you can see that, for example, if you're rotating here, right, you rotate, if you're on the land here, you rotate, you're in daytime, and then you go over into the darkness, and then that's nighttime. That's why it's night. And then you spend the whole night rotating in the darkness, and there's no sun coming. There's no sunlight. And then you rotate over back across the terminator on this side, and you rotate back into the light, and then that's morning, and that's where the sunlight is. That's where the light is again. So I hope you can see from that light from the sun does not get spread over the surface area, the entire surface area of the Earth. The light from the sun falls onto the Earth. It doesn't spread to the back of the Earth and all over the Earth. And again, here, where the sunlight is falling totally perpendicular to the surface, it's falling with full intensity, and it's quite hot here, right? Sunlight is actually quite warm. Just above the Earth, the flat plane here, the disk that exists here, that's the cross-section of this sphere. So the cross-section of intercepted light that falls onto here is actually quite intense in its raw value. It has an equivalent temperature of 121 degrees Celsius as a black body. So it's actually quite hot, and when it falls onto the surface, to the oceans have an albedo of almost 0. So almost all of the solar energy is absorbed on the oceans. So that's quite a bit of energy. On land, there's a lot of land which is quite dark too, and so you can heat land up to quite warm temperatures, as we know actually happens, right? You experience a black asphalt in the summertime on parking lots or beach sand. When you're at the beach in the summertime, you can see that it's quite hot, and it's quite hot because this real incoming solar energy is quite intense and is able to generate those temperatures. Now, when you guys, you physicists with PhDs and you climate physicists with PhDs, when you take this input and spread it on paper, in your math on your paper, over to the back side where that light doesn't actually fall, you're mathematically diluting that light, because light has an intensity, and the intensity is given by its density, right? So when you divide the density over to the surface area where it never exists, where it doesn't fall upon, you're just arbitrarily diluting the sunlight. You're actually diluting it by a factor of 4, because you take this disk, this intercept disk here, and you divide it over the entire surface at once, even though you can see that doesn't actually happen. And so that ratio is a factor of 4, or a quarter. So a quarter intensity, you're basically taking this disk of intensity and making it a quarter as strong, 25% as strong, and you're spreading it over the entire surface of the Earth at once. Well, you can see that that's not what happens, even with the Earth rotating. Even with the Earth rotating, what happens is points on the Earth's surface rotate into the intensity as it exists in real time. So you can't take this intensity and just divide it by 4 and spread it over the entire surface of the Earth at once, because that's simply not what exists, right? So a quarter of the intensity, if you were to figure out what zenith angle that would be equivalent to, you take the inverse cosine of 0.25, and that is somewhere, I think it's 75 or 76 degrees. So what you're doing by making solar input a quarter of its actual value is you're making it equivalent to the input experienced at 75 degrees north of the, well, in this case, you could say north of the equator, if the equator was pointing to the zenith, pointing to the sun. So 75 degrees north latitude is beyond the Arctic Circle, I do believe that's beyond the Arctic Circle. So you're basically making the sun as strong as is felt very close to the North Pole and South Pole, beyond the Arctic and Antarctic circles. That's how strong you're making the sun. That's how much you're reducing it to by dividing it by 4, making it 25% as strong by spreading this incoming light from the sun over the entire surface. So I hope that this empirical demonstration is enough for the PhDs in physics and the PhDs in astronomy and the PhDs in climate physics and climate science, and then just the regular people out there. I hope you can understand what this demonstration has shown you. Now, this globe did cost a little bit of money. I'm going to maybe go see an oil company about getting reimbursed for that. How about that, hey? Okay, back to my video. Okay, so I hope that empirical demonstration was useful for you. That was a real empirical refutation of climate physics, of climate alarm, of climate theory, and of much of the value and use of the modern scientific method itself. Like I had said at the beginning, I had thought that it was going to be a little bit embarrassing doing that presentation, given the audience it was intended for. And that is there a little bit. I have done this with my 6-year-old daughter, who's graduated kindergarten now, and she thought it was quite a thrill, and she really got a kick of how daytime turns into nighttime, and how there's this band called the terminator, which divides where the sunlight is falling on one hemisphere versus the dark hemisphere that's in the shadow of the sunlight. She thought it quite interesting that sunlight doesn't spread over the entire surface area of the Earth at once. And, you know, I would happily do demonstrations like that for children and kindergartners. It's about the kindergarten level of demonstration, I think. It's useful for kindergartners, and I think they can understand all concepts. My 6-year-old certainly could understand it all. So I really hope that it just really helps the PhDs in physics, and the PhDs in astronomy and astrophysics, and the PhDs in climatology, and the other people who have no education, higher education whatsoever beyond high school, who likewise say these things and repeat these things that is said by people who believe in climate alarm. I hope it's useful for you to see that, you know, sunlight doesn't actually spread over the entire surface area of the Earth at once. And that claiming that is not actually basic geometry, and area is important, but area is important because it refutes entirely what you're saying about this. I know that this demonstration might be useful for the type of physicists who might study the aurora, or physicists who work at CERN, or physicists and astrophysicists who've done photometry for a living all their lives, and certainly for practicing climate physicists and climatologists. Such people have all stated this to me, have all stated that it's basic geometry that sunlight falls over the entire surface area of the Earth at once, that incoming sunlight does this. That's what they've said about incoming sunlight, that it does this, and not that it does this. So I hope that that empirical demonstration, and I know that that flashlight wasn't a real sun, and that the globe I had wasn't the real Earth, and I wasn't continuously rotating it at the correct scale rate, but nonetheless I did show it, rotating just with my finger. I rotated a little bit so you could see how a point on the surface of the Earth will transition from in the shadow, which is nighttime, into daytime, and that's morning, and then how it would transition from daytime to darkness, which is nighttime, and that's dusk, dawn, and dusk. So I did give that demonstration. I hope that was useful. So sunlight, actually, the incoming, instantaneous, per second, the incoming sunlight falls over a hemisphere like this, okay? And the Earth rotates underneath that, and points on the surface rotate into the actual physical intensity that's actually occurring there. And that actual physical intensity of the sunlight can actually be quite hot, quite warm. It actually has a tremendous amount of energy. If you see this little graphic here, this is a cumulonimbus cloud, and I love to show those because that's basically a lake, a small lake being risen to 30,000 feet altitude. That takes a tremendous amount of work, a tremendous amount of heat to do that. And that heat and that work and the energy to do that comes from sunlight. It came from sunlight. Sunlight did that. Sunlight created the climate. In this PhD physics, modern PhD physics, modern PhD climate physics of flat earth theory, which is peer-reviewed by them and is accepted by them, where sunlight falls evenly over the entire surface area of the Earth at once. The climate has to create itself because they've diluted sunshine on paper to being only minus 18 degrees Celsius. And so then they invent this scheme that they call a greenhouse effect, even though it's not actually how a real greenhouse functions. So it actually just steals the word greenhouse because a greenhouse, has a connotation of warmth. So they've simply stolen that as a concept and created this fake thing, which isn't how an actual greenhouse works, and have used this or invented this thing to create the climate so that the climate can create itself, right? Now, one thing that's interesting is that according to climate physics, if the climate creates itself, then it should be able to create itself at any time. But you might notice that cumulonimbus clouds are actually only created in the daytime, and typically afternoon, after the sun has actually had time to warm up points on the surface which have rotated underneath the intensity of the sunlight, incoming sunlight in real time. It's typically only after that, well, it is actually always, not just typically, but always after the sun has been able to influence the surface and input heat and do work on the surface, that the cumulonimbus clouds can be risen up to 30,000 feet. Now, in climate physics, cumulonimbus clouds should be able to appear in the middle of the night, say 3 a.m. They should be able to appear randomly at any time of the day. The distribution of the times of creation of cumulonimbus clouds should be entirely linear with the hour of the day. So at any given hour of the day, between 0 and 24 hours, 23 hours, you should have an equal probability of getting cumulonimbus cloud since, according to climate physics, the climate creates itself, independent of sunshine, which is only minus 18 degrees Celsius, anyways, in their reckoning. So that's another empirical point that sort of indicates that actually it's the sun creating the climate, not the climate creating itself, which is, of course, thermodynamic, pseudoscience. I mean, it flies in the face of the first and second law, like in the most basic analysis. So anyway, I hope that this has been useful. Again, this is a real empirical demonstration that I hope that PhDs in physics can understand. You really got to see the pretend sun shining light on the hemisphere of the Earth. You really got to see how that hemisphere creates a shadow behind itself. So the input hemisphere that absorbs the sunlight then obviously blocks the rear-facing hemisphere and puts that rear-facing hemisphere in shadow, and we call that nighttime. And so you don't actually have that incoming solar energy is being spread over the full sphere of the Earth, as is said here, as if that's basic geometry. This basic geometry that they have schemed where sunlight falls over the entire surface area of the Earth, as if the Earth is literally equivalent to a flat plane. I'm sorry, but that's not actually basic geometry. That's actually wrong geometry. It's wrong. Wrong geometry. The good geometry, the true geometry, is where sunlight is falling over a hemisphere and points on the surface, because the Earth is rotating, rotate under that real-time intensity. And that real-time intensity is quite sufficient indeed to create the climate. And the idea that the climate could create itself out of nothing is obviously totally in violation of the second law of thermodynamics, also the first law of thermodynamics, and all that good stuff. So I hope this was useful for the kindergarteners who've been watching, and also the PhDs in physics who, get really big grants from the government to spread flat earth theory and teach flat earth theory to children and to their PhD students, and to get their PhD students all believing in flat earth theory. I hope this was useful to you, and hopefully if you start to believe in spherical earth theory, it doesn't interfere with, these huge grants that you guys all get to well, whatever, do whatever, make stuff up, Okay, have a good night. Bye.